A lab in Leipzig, late in the evening, and on the table sits a skull that hasn't seen daylight in 36 centuries. A researcher leans in with a small drill, aiming not for the skull's crown or its jaw, but for a dense knot of bone tucked behind the ear. The petrous bone, barely bigger than a walnut. It's an odd target until you understand why. That single piece of bone preserves DNA up to 100 times better than anything else in the human skeleton. In a place like Greece, where heat and humidity chew through ancient genetic material within a few centuries, the petrous bone was the only real way in. For over 100 years, this was a question archaeology alone couldn't touch. Were the people who raised the palace at Knossos and filled the shaft graves of Mycenaean the direct ancestors of Greeks living today? Or had that bloodline been erased somewhere across 4,000 years of invasion? Slavs, Romans, Ottomans, Crusaders, one wave after another. In 1830, a German historian named Jakob Philipp Vollmerayer answered that question in the most explosive way he could. The ancient Hellenic race, he wrote, had been wiped out in Europe entirely. Every Greek alive was, in his telling, descended from Slavic settlers who had simply taken over the name. That single claim lit a fuse that burned for 170 years, historians argued. Nationalists on both sides dug in. And for almost all of that time, nobody could actually prove anything. The bones were too old, the DNA too degraded. The tools simply didn't exist yet. Then, starting in 2013 and accelerating through 2023, a series of studies finally cracked those bones open. If you want to know what ancient bones actually say instead of what politics wants them to say, stick around. And if you're new here, subscribing takes about one tap. The first shock came out of a cave on a plateau in eastern Crete, where 37 sets of teeth had been sitting in the dark for 3,500 years. Start with the man who got it wrong. When Arthur Evans broke into the Palace of Knossos in the early 1900s, what he found stopped him cold. Frescoes, indoor plumbing, a sprawling multi-story complex so vast it may be the real-world source of the labyrinth myth. Evans looked at all of it and decided people that sophisticated couldn't have come from the local Aegean. He proposed they'd arrived from North Africa or the Middle East instead. That idea shaped Minoan scholarship for decades. Their script, Linear A, still undeciphered to this day, seemed to lean toward Egypt. Their bull-leaping frescoes had no obvious parallel anywhere nearby. The foreign origin theory held. Then in 2013, a team led by George Stamatoianopoulos at the University of Washington, working with Jeffrey Huey at Hartnell College, pulled mitochondrial DNA from 37 Bronze Age skeletons found in a cave ossuary on the Lassithi Plateau. They ran the results against 135 modern and ancient populations. The Minoans carried 21 distinct mtDNA markers. 15 were shared with Neolithic and modern Europeans. 6 belonged to the Minoans alone. Not one matched an African population. The strongest genetic match wasn't Egypt. It wasn't Libya. It wasn't the Levant. It was Neolithic populations from southern Europe. And, more strikingly, modern Cretans still living on that same Lassithi Plateau, 36 centuries later. Stamatoianopoulos's conclusion was direct. The Minoans descended from the Neolithic people who first reached Crete around 7000 BC, part of a much larger Anatolian farming migration. Evans had looked at the art and imagined foreigners. The DNA told a simpler story. Locals, whose ancestors had already been living on that island for 4,000 years before a single stone of the palace was ever laid. Head south to the Peloponnese coast, to a cave mouth overlooking the sea at a place called Franxthi. People lived in and around this cave from roughly 38,000 BC all the way through to 3000 BC, one of the longest unbroken habitation records found anywhere in Europe. The earliest of them were Paleolithic hunter-gatherers, and they carried mitochondrial haplogroups U5 and K, among the oldest human lineages known on the continent. Around 7000 BC, everything shifted. The Neolithic Revolution arrived from western Anatolia, carrying with it farmers whose ancestry looked nothing like the hunter-gatherers already living in Greece. The site of Barkin in northwest Turkey, dated to roughly 6600 to 6500 BC, marks something close to the launching point for that migration across the Aegean. Early Greek Neolithic settlements, Franxthi itself, Knossos on Crete, Polyambella and Ravenna up in the north, all cluster around that same window. These weren't scattered temporary camps. They were established farming communities, complete with ceramics, domestic cereal crops, and groundstone tools. Here's where the data gets surprising. A 2022 study in Scientific Reports sequenced 42 Neolithic genomes from across Greece, and found what the authors called striking genetic homogeneity for the maternal line throughout the entire Neolithic period. Put plainly, once those Anatolian farmers settled in, the maternal genetic profile across Greece barely shifted for more than 2,000 years. The paternal record backs this up. Y chromosome haplogroups G2A and J2, both hallmarks of these Neolithic Anatolian farmers, became dominant across the region, and they still show up at high frequencies in Greeks today. For roughly 3,000 years, Greece's genetic recipe stayed remarkably fixed. Then, somewhere between the 4th and 2nd millennium BC, two entirely new ingredients arrived from opposite directions, and the recipe stopped being simple. Start with a number that doesn't belong. The 2017 Lazaridis study found that both Minoans and Mycenaeans carried a substantial genetic component, somewhere between 15 and 25%, tracing back to ancient populations from the Caucasus and Iran, closely resembling samples from a site called Ganj Dareh in the Zagros Mountains. That component simply isn't present in the earlier Greek Neolithic genomes. It shows up somewhere between the final Neolithic, around 4100 BC, and the early Bronze Age, a migration window spanning the 4th to 3rd millennium BC. On Crete, this eastern gene flow leaned heavily Anatolian, likely tied to the same maritime trade routes that turned the early Bronze Age Aegean into a genuine crossroads. On the mainland and in the Cyclades, the signal tilted differently, more specifically Caucasus in character, pointing to a separate migration route or source population entirely. The Skortanioti 2023 study, built on 102 genomes, confirmed the asymmetry directly. Eastern gene flow was not symmetric across the Aegean. Crete absorbed one stream. The mainland and Euboea absorbed another. Two populations living a short sea crossing apart were quietly pulling in different ancestral threads from the east, a genetic divergence that would echo all the way into the Mycenaean era. That eastern layer settled in and became part of the baseline. The real dividing line between Minoans and Mycenaeans came from somewhere else entirely, the open grasslands north of the Black Sea. Move north and east now, away from the Aegean shoreline entirely, out onto the open grassland between the Black Sea and the Caspian. Around 3000 BC, a semi-nomadic pastoralist culture, known as the Yamnaya, began one of the most consequential migrations in human prehistory. They carried a distinctive genetic signature, Eastern European hunter-gatherer ancestry, and over the following 1,000 years, that signature reshaped the gene pools of Central and Northern Europe almost entirely. In mainland Greece, this steppe-derived ancestry shows up in the archaeological record by the Middle Bronze Age, around 2000 BC. The 2017 Lazaridis study measured it directly in Mycenaean samples, 4 to 16%. Small, but unmistakable. The timing here matters enormously. This steppe ancestry arrived in the very same centuries that the Greek language, an Indo-European branch, first took root in the Aegean. Genetic studies from 2024 support a migration path running directly from Eastern Europe, or by way of Armenia, straight into the Greek mainland, a separate route entirely from the westward Bell-Beaker expansion that carried steppe ancestry into Iberia and Britain. Evidence from a Mycenaean tomb at Kastruli, near Delphi, helped researchers document what they called the end process of the Yamnaya expansion in what's known as the Southern Arc. By the time that steppe signal reached Greece, it had thinned dramatically compared to what shows up further north. David Reich at Harvard pinned down the window precisely. Neolithic Greeks, right down to the final Neolithic around 4100 BC, carry neither the eastern nor the steppe component. So both arrived in roughly the same 2,000-year stretch. The steppe ancestry that helped forge the Mycenaean world had one sharp limit. It stopped at the water's edge. Across the strait on Crete, the Minoans stayed untouched. Look at the frescoes and you'd never tell them apart. Minoans and Mycenaeans both painted dark-haired, brown-eyed figures on their walls. Both carried the same genes for hair and eye color, and both shared at least 3/4 of their overall ancestry. Visually, side by side, they're nearly identical. Genetically, one detail splits them apart. That 4 to 16% steppe component sitting in Mycenaean DNA that Minoans simply don't have. Small as it is, it marks a distinct migration event, one that reached the mainland and, at least at first, never touched the island. Iosif Lazaridis summed up the bigger picture this way. The spread of farming populations was the decisive moment when the major elements of the Greek population were already in place. The steppe layer was an addition on top of that foundation, not a replacement of it. The Skortanioti 2023 study added a twist to that story. Steppe-related ancestry did eventually reach Crete, just gradually, across the 17th to 12th centuries BC, the same centuries when Mycenaean political influence over the island was intensifying, right up through the apparent Mycenaean takeover of Knossos around 1450 BC. That cultural takeover left a genetic signature behind it. As the mainland's power expanded onto Crete, it brought steppe DNA along with it. The Minoans weren't overrun by strangers. They were absorbed by their closest relatives. Relatives who happened to be carrying an extra 4 to 16% of something from the steppe. Two Bronze Age civilizations, siblings wearing slightly different genetic cocktails. What came next would test whether that shared core could survive the collapse, and the centuries of invasion that followed it. Unprecedented in the global ancient DNA record. That's the exact phrase researchers reached for. The Scortanioti 2023 study wasn't just mapping ancestry across the Aegean. Buried in the data was something that had never shown up at these frequencies in any ancient DNA dataset anywhere on the planet. Consanguineous endogamy, systematic marriage within closely related groups. Across the 102 ancient Aegean individuals sequenced, a striking number carried long runs of homozygosity, identical DNA stretches on both chromosomes, the genetic signature of unions between first or second cousins, repeated generation after generation. This wasn't a quirk found at one site or confined to one century. It showed up in the Neolithic, in the early Bronze Age, and straight through the Middle and Late Bronze Age, on Crete, on the mainland, and out on the islands alike. The researchers read this as evidence of tight kinship-based marriage rules woven into prehistoric Aegean society, bloodlines deliberately kept within a defined group, a clan, an extended family network, something structured and sustained. The effect on genetic preservation was enormous. Endogamy functions like a bottleneck filter. It cuts down outside gene flow, amplifies founder lineages, and effectively locks a population's genetic profile in place across centuries. 241 people, every district of the Peloponnese, 2.5 million genetic markers. That was the design George Stamatoianopoulos and his team built in 2017, running modern samples through principal component analysis and admixture modeling against European reference populations, including the Slavic homeland groups themselves, Poles, Belarusians, Russians, Ukrainians. The first result landed cleanly. On the PCA plots, Peloponnesians clustered firmly with Sicilians and Italians, not with any Slavic population. The overlap with Slavic groups was minimal at best. The second result put a number on it. Quantitative admixture analysis placed Slavic ancestry across Peloponnese subpopulations somewhere between 0.2 and 14.4%. Shared ancestry with Slavic groups stayed consistently under 15%. Shared ancestry with Italians, by contrast, ran 85 to 96%. A detail nobody expected sat buried in the same data. The specific communities Fallmer had pointed to by name, the ones he offered as proof of total Slavic replacement, showed no significant Slavic ancestry at all. A third result added two names to the story. The study identified two genetically distinct subgroups within the Peloponnese, the Maniotes and the Tsakones, each dramatically different from the general population, and from each other. Neither carried meaningful Slavic ancestry. The paper's own conclusion was blunt. This study rejects the theory of extinction of medieval Peloponnesians, a claim debated since the year Greece became a nation collapsed against 2.5 million data points. But the Manios and the Tsakones the study flagged turned out to be an even bigger story on their own. Head to the southern tip of mainland Greece, down into the Mani Peninsula. Narrow, mountainous, short on farmland, dotted with defensive tower house villages. For centuries, the deep Maniotes who live here have kept a patrilineal clan structure, oral traditions claiming descent from medieval nobility, and a reputation for staying fiercely to themselves. In February 2026, a study led by Leonidas Romanos Davronoglu, working across Oxford, Tel Aviv, and Athens, sequenced Y-DNA and mitochondrial DNA from 102 deep Maniotes, using next-generation sequencing, then checked the results against over 1 million modern people and thousands of ancient DNA samples worldwide. The paternal result was extraordinary. Roughly 80% of deep Maniote men carry the West Asian haplogroup JM172, known as J2A. The subclade JL930 alone accounts for about half of all male lineages. These haplogroups trace directly back to Bronze Age and Iron Age Greece, and they're nearly absent everywhere else on Earth today. More than half of living deep Maniote men descend from a single male ancestor who lived in the 7th century CE, a bottleneck that lines up with plague, warfare, and the demographic chaos of the migration period. The paternal lineages tied to medieval Slavic admixture, common across the rest of mainland Greece, were essentially missing here. While the surrounding region mixed, Deep Mani preserved southern Greece's pre-medieval genetic landscape almost untouched. The team found next to no matches to any other population on the planet. Science magazine put it plainly. This remote Greek culture has been a genetic island for 4,500 years. The Deep Maniots fought off the Slavic migrations with stone towers and mountain terrain. Across the peninsula, the Sacones pulled off something remarkably similar, through a completely different mechanism. A living language can be a fossil. On the eastern slopes of Mount Parnon, in the region the ancients called Sinoria, a small population still speaks Saconian, a dialect that doesn't trace back to the standard Koine Greek underlying almost every other modern Greek dialect. It traces to ancient Doric, the language of Sparta itself. Their name likely comes from a corruption of Lacones, meaning Laconians, recorded by medieval Byzantine writers. Fallmarier had a specific theory about them. He argued that Sacones were actually a Slavic tribe that had slipped into the Peloponnese ahead of the main Slavic wave. The 2017 Stamatoiannopoulos study tested that claim directly. PCA and admixture analysis placed the Sacones well outside both the general Peloponnese population and the Slavic reference groups. No significant Slavic ancestry turned up in their genome at all. Their genetic distinctiveness traces to geographic isolation. Mount Parnon and the terrain around it formed a natural wall that limited gene flow for centuries. The same isolation that kept their archaic dialect alive also kept their pre-medieval genetic profile intact. Together, the Sacones and the Maniotes formed two independent natural experiments. Both escaped the demographic shifts that reshaped the rest of mainland Greece, through two entirely different accidents of geography. The Maniotes behind a defensible peninsula, the Sacones behind a mountain wall. One peninsula, one mountain range, both carrying Bronze Age lineages forward into the present day. Crete, the largest Greek island, ran a version of this same experiment, just at a far bigger scale. Put Crete and the mainland side by side after the Bronze Age, and the timelines split apart. The Scortanioti 2023 study tracked ancestry shifts across the Aegean, from Neolithic through Iron Age, and found that Crete consistently lagged behind in absorbing outside gene flow. Steppe ancestry showed up on the mainland by around 2000 BC, but it didn't reach Crete until 1700 to 1200 BC. And even then it arrived slowly, not as a sudden wave. The Slavic migrations of the 6th and 7th centuries CE left 30 to 60% ancestry across the Balkans. Crete barely registered it. The Olalde et al. 2023 study, built on 136 individuals, confirmed that the Dodecanese and Crete were mostly spared, showing much lower Slavic ancestry than anywhere else in the region. Distance played a role. Crete sits 100 kilometers from the nearest mainland coast, but distance alone doesn't explain it. Crete's Minoan-era maritime networks had already made the island a hub rather than a backwater, and through the Byzantine period, its strategic value meant it was actively defended against exactly the kind of migration pressure that reshaped the mainland. Modern Cretans still carry high frequencies of Y chromosome haplogroup J2A1D and mitochondrial haplogroup T2E, both reflecting deep continuity from the island's Minoan population, at rates notably higher than on the mainland. The Huey and Stamatoiannopoulos 2013 study had already pointed to this. The strongest modern genetic affinity with the ancient Minoans belonged to people living on the Lassithi Plateau, the exact same plateau where those Bronze Age bones were first excavated. Crete preserved its Bronze Age DNA at scale, functioning as a genetic ark for the whole island. In a handful of isolated mountain villages there, that preservation went even deeper, deep enough to produce something biologists had never documented before, a mutation that may genuinely protect against heart disease. In a cluster of mountain villages in central Crete, researchers found something that shouldn't exist at these numbers anywhere in Europe. In Enogia and the surrounding Mylopotamos region, a specific mutation called APOC3R19X turns up in 1.9 to 4% of the local population. Everywhere else on the continent, that same variant sits below 0.05%, essentially absent. APOC3R19X is a loss-of-function mutation in the apolipoprotein C3 gene. Carriers show measurably lower triglyceride levels and higher HDL, the good cholesterol, real, quantifiable protection against cardiovascular disease. The mutation wasn't brought in from anywhere. It appears to have been amplified through genetic drift, a founder effect magnified by centuries of isolation. the same isolation that preserved these communities' Minoan-era lineage signatures in the first place. Anaogia sits at 740 meters in the mountains of central Crete, and historically, it was one of the most self-contained communities on the entire island. Marrying within the village was simply the norm for generation after generation. Put plainly, this is genetic isolation showing its full range of effects at once. Neutral on one side, preserving ancient lineage patterns untouched, and functional on the other, amplifying a random variant until it became medically significant for an entire community. The same bottleneck that kept Slavic and Ottoman DNA out of these villages also turned one obscure mutation into a local shield against heart disease. What isolation did at the molecular level in a handful of Cretan villages raises a bigger question at the national scale. What did the largest empires in history actually leave behind in Greek DNA? Rome controlled Greece from 146 BC through the transition into the Byzantine era. Nearly 5 centuries of direct administration. The expectation going in was simple. Somewhere in that span, Italian DNA should show up. The Olalde et al. 2023 Balkans study, built on 136 individuals from the first millennium CE, found almost none of it. The study's own wording, little ancestry contribution from peoples of Italic descent. Even once cremation gave way to burial in the 2nd century CE, opening up far more samples to test, the Italic signal stayed effectively invisible. What the study found instead was a large-scale influx of people from Western Anatolia moving into the Balkans throughout the imperial period, mirroring a shift already documented in the city of Rome itself, where the empire's eastward reach pulled Anatolian and Eastern Mediterranean populations westward rather than the other way around. One case stood out on its own. A 16-year-old male excavated from a Roman necropolis in the Balkans carried East African ancestry, a small but vivid marker of just how cosmopolitan the empire's reach was, even out at its frontier. Roman-era chronicles recorded new faces arriving in the provinces and often labeled them Greeks, because the eastern half of the empire had spoken Greek for centuries before Rome ever annexed it. The demographic current ran east, not west. The Ottoman era, 1,300 years later, followed a nearly identical pattern. 4 centuries of occupation, from 1453 to 130 to 60%. That's the range the 2023 data lands on for Slavic ancestry across the Balkans. But that range hides enormous variation depending on where you look. The Olalde et al. 2023 study and the 2025 Histogenes project, which sequenced over 550 medieval Slavic genomes, arrived at the same conclusion from different data sets. The Slavic migrations of the 6th and 7th centuries CE rank among the largest demographic events in medieval Europe. In Eastern Germany and Poland, genetic replacement topped 80%. In the Balkans, the contribution settled between 30 and 60%, running higher in the north, Serbia, Croatia, and lower in the south, in the Peloponnese, Crete, and the Dodecanese. The Histogenes Consortium traced the Slavic homeland itself to a stretch of land running from southern Belarus to central Ukraine, matching what archaeologists and linguists had proposed for decades. One finding surprised the researchers directly. This wasn't an invading army. It was families. Genetic evidence showed no meaningful sex bias. Men and women migrated in comparable numbers and contributed equally, ruling out the old picture of conquering warriors alone. In Greece specifically, the signal is real but moderate. The general population carries under 10% Slavic admixture on average. The 2017 Peloponnese study measured it at 0.2 to 14.4% by subregion, with the lowest figures showing up in the most geographically isolated pockets. Carles Laluesa Fox, senior author on the 2023 Balkans study, put a fine point on it. Slavic ancestry turns up all across the Balkans, including in Greece and other countries with no Slavic national identity at all. The genetic map simply doesn't follow the linguistic one. That imprint was real, measurable, and politically uncomfortable, sitting inside a country that defines itself through unbroken Hellenic continuity. The 4 separate mechanisms, working at once, kept that core intact. Start with geography. Greece's terrain, mountain ranges, narrow peninsulas, scattered islands, created natural barriers that slowed or outright blocked demographic waves. Slavic migrations that swept unopposed across the open Balkan plains lost momentum the moment they hit Greece's mountain interior. Islands like Crete were effectively shielded by water alone. Add endogamy. The consanguineous marriage patterns Scortanioti and her team documented back to the Neolithic weren't a one-time Bronze Age quirk. Kinship-based marriage norms persisted in rural Greece well into the modern era, limiting outside gene flow at the community level for thousands of years. generation after generation. Then, religious segregation. Under Ottoman rule, the millet system kept Christian and Muslim communities separate socially and matrimonially. Intermarriage was rare enough that 4 centuries of Ottoman administration left behind only 6 to 12% West Anatolian ancestry, even in the most affected regions. And finally, population density. Greece wasn't thinly settled when the Slavic migrations arrived. Dense existing populations, especially in the Peloponnese, on Crete, and across the islands, meant incoming migrants were absorbed into a much larger gene pool rather than replacing it outright. These 4 factors reinforced each other directly. Mountains channeled migration into predictable, narrow routes. Endogamy filtered whatever got through those routes. Religious separation added another layer of resistance during the Ottoman centuries, and sheer population mass diluted the rest. The preservation was never one single mechanism. It was a system: geography, kinship, religion, and demography, all operating in parallel across 4,000 years. And the north-south gradient visible in Greek DNA today is the direct fingerprint of exactly where that system held and where it gave way. Not every region of Greece tells the same genetic story. The Lazaridis and Olalde 2023 data shows Aegean Bronze and Iron Age ancestry, the Mycenaean baseline, running strongest in Greek Macedonia at 38.8% and the Peloponnese at 24.7%. That same signal drops off sharply in the Cyclades, Crete, and the Dodecanese, where Roman-era Anatolian ancestry takes up a much larger share instead. Northern Greece, Thrace, Macedonia, absorbed more Slavic ancestry than anywhere else in the country, which tracks with its position as the first landfall for migrations moving south out of the Danube basin. The Peloponnese worked more like a funnel. Slavic settlement pushed into the accessible lowlands and valleys, but stalled 13 years. And the picture keeps sharpening rather than falling apart. In 2013, Hughey and Stamatoianopoulos pulled the first reliable Minoan mtDNA from 37 individuals, confirming the Minoans as descendants of local Neolithic Aegean populations. In 2017, Lazaridis and his team assembled the first nuclear genome dataset from Minoans and Mycenaeans, 19 individuals total, and found 3/4 Anatolian farmer ancestry, plus the Caucasus and Iran-related component, plus that small step addition unique to the Mycenaeans. Modern Greeks came out of that study as the closest living relatives of the Mycenaeans. That same year, Stamatoianopoulos and his team tested 241 Peloponnesians against 2.5 million SNPs. Fallmerayer's extinction theory didn't survive the analysis. Slavic ancestry landed at 0.2 to 14.4%. By 2022, a Neolithic mtDNA study covering 42 genomes established maternal genetic homogeneity across the entire Greek Neolithic. In 2023, Scortanioti and colleagues expanded the dataset to 102 Aegean genomes, spanning Neolithic through Iron Age, uncovering endogamy at levels never seen before in the global ancient DNA record, and confirming that steppe DNA reached Crete gradually, between the 17th and 12th centuries BC. That same year, Olalde and his team mapped the Balkans from the Roman frontier through the Slavic migrations using 136 genomes, measuring Slavic ancestry at 30 to 60% across the region, with sharp drop-offs in southern Greece and the islands. In 2026, Davranoglu and his team sequenced deep Maniot Y-DNA and mtDNA from 102 individuals, finding Bronze Age lineages preserved for 4,500 years, and a single ancestor bottleneck dating to the 7th century CE. Each study built directly on the one before it, and the cumulative picture holds steady. Ancient Aegean ancestry remains the dominant thread running through modern Greek DNA, layered by every subsequent migration but never erased by any of them. The next generation of research will only sharpen this further. The Histogenes Consortium alone sequenced 550 medieval Slavic genomes in its latest release, and ancient DNA extraction keeps getting more precise. The question ahead isn't whether that continuity exists, it's how deep the local variation goes. Persistence isn't the same as purity, and continuity isn't the same as isolation. Lazaridis, the same researcher who documented that 70 to 80% Mycenaean connection, also noted that the Greeks have always been a work in progress. The Neolithic layer dominates, but every era after it left a mark. Some things still sit outside the reach of genetics entirely. The Minoan script, their art, their maritime world, none of that comes from a DNA sample. Linear A remains undeciphered. We can confirm the Minoans were locals. We still can't read what they wrote, The exact mechanism behind the steppe ancestry's arrival in Greece stays unsettled too. A slow trickle through generations of contact along the Balkan frontier, or something closer to a single defined migration pulse. David Reich himself said the timing needs further samples from broader time periods and wider geography before it's resolved. Endogamy's role is locked in for the Bronze Age, but its persistence through the classical, Hellenistic, and Byzantine periods hasn't been mapped with ancient DNA at all. Those centuries remain thin on samples. The Deep Maniots hold their own paradox. Their paternal DNA is almost entirely closed off. Their maternal DNA tells a different story. Women arriving from elsewhere in the Mediterranean, and occasionally from Africa, marrying into the community across the centuries. The Davronoglu study called this the untold history of Deep Maniot women, obscured for generations by oral traditions built almost entirely around the men. What Greek DNA reveals, in the end, isn't a frozen population. It's a layered one, a Neolithic foundation laid down 9,000 years ago, built up with Eastern and steppe additions in the Bronze Age, tested by Slavic and Ottoman migrations in the medieval centuries, and still standing against every historical pressure into the present. 4,000 years of empires, invasions, and migrations, and the genetic core held. So what else are those bones still hiding?